Hello everyone and welcome back to our channel Quaint. Have you ever looked at the flow of water from a faucet or watched smoke rise from a candle and wondered how does nature decide where that flow will go? Believe it or not, science still doesn't have a complete answer. And if you could solve this problem, if you could solve this puzzle, you could earn $1 million. Yes, this is right. This prize money of $1 million was declared by Clay Mathematics Institute in the year 2000. And this is one of the legendary Millennium Prize Problems in mathematics. Okay, name of the problem here in this discussion, name of the problem is Navier-Stokes existence and smoothness problem. There are actually 7 problems for which the prize money was declared by Clay Mathematics Institute. 7 problems. And out of those 7 problems, only 1 problem was solved by a mathematician. But here, today in this video, we are talking about a different problem. Okay, and for this problem also, there is a prize money of $1 million. Name of the problem is Navier-Stokes existence and smoothness problem. You might have heard the name of this equation, Navier-Stokes equation. Actually, there is a set of equations. All those are partial differential equations. And scientists and engineers are already solving this set of equations for solving different fluid flow problems. Whether the fluid flow problem is steady or unsteady, compressible or incompressible, irrotational or rotational, inviscid or viscous, whatever be the flow, for all the cases, Navier-Stokes equations are solved. Or other forms of the equations are also available, like Euler's equations. Means if you don't want to consider the effect of viscosity, means in case of high speed flows, Euler's equations are used, because in that case, inertia forces are very greater than the viscous forces. So in those cases, viscous forces can easily be neglected, and the resulting equations are known as Euler equations. Anyway, we are talking about here only Navier-Stokes equation. So actually the challenge is not finding a specific solution to a given problem. Okay, here challenge is somewhat different. Challenge is to prove mathematically that the equations, the Navier-Stokes equations, give us a unique and smooth solution. And there should be no sudden infinities, or there should be no physical impossibilities. And all these things should be independent, means all these equations should be applicable for 3 dimensions, whatever be the starting condition. Okay, only 3 dimensions. And one more thing I want to mention here, that this problem is not for compressible flows. Okay, this problem for which the prize money has been announced by Clay Mathematics Institute, that is only for incompressible flow. And also 3 dimensions must be there, not 1-dimensional, not 2-dimensional. The flow must be 3-dimensional, incompressible and 3-dimensional. And what is the challenge? Challenge is to prove whether or not, you have to prove that mathematically whether or not those equations give us a unique and a smooth solution. And I have already mentioned what is the meaning of a smooth solution. There should be no infinities. There should be no physical impossibilities. And that should be irrespective of the starting condition in 3 dimensions. Okay, and you know that if you could really solve this problem, then already one problem has been solved. So if you could solve this one, I am talking about Navier-Stokes. Okay, if you could solve this one, you could earn that prize money. And you know that solution of those equations are actually required. Okay, because many problems are there. You know, in the field of biology and medicine also, this is used. Whether the flow is of air or water or blood. Means scientists and engineers are using to predict blood flows in arteries. Flow of air past aircrafts. Okay. Flow of air past aircrafts. Flow through nozzles, flow through pipes, flow through turbines. So many problems are there. And that's why there are big industries. The name of those common name is CFD. Actually, CFD is the name of the subject. Okay, computational fluid dynamics, where actually Navier-Stokes equations are solved. Okay. Anyway, we should focus only on this problem here, the challenge. Challenge is to prove the uniqueness and smoothness of the Navier-Stokes equations for incompressible and three-dimensional flow. So if you got a love for fluid dynamics and if you have a deep interest in mathematics, in that case, you could try to solve the problem. Maybe you could earn the prize money. Anyway, so this was all about it, today's topic. And if you found this video interesting, so please like, share and subscribe to our channel. This is the end of this video. Thanks for watching.